My another tutorial is the chapter Kinematics, and we are solving from Cambridge Admit book. This is one challenge question I'm trying to show you from exercise 16.2, which is in page 418. So question number 13. Let's see the question what written here. A particle starts from a point 2, moves in a straight line so that its displacement is given by s equals to that expression. First equation is find expressions for velocity. This is the first question, and the acceleration a of the particle at time t seconds. So all we know, while we are how to get the velocity from displacement, we just have to differentiate that one. So let me differentiate to get the velocity. The expression is given here, d by dt of 2t sine pi t by 3. We have to apply here product rule because this is the part u and this is the part b, two variables separately given here as a multiplied form. So let you consider u equals to 2t and let you consider b equals to sine pi t by 3. So now differentiate du by dt. From here we got 2, and if we differentiate this b part from here, actually don't mix out this b and that b. This is actually the or what you can say, we consider it as a b. This is not the velocity. dv by dt equals to, we have to differentiate sine and gives us a constant multiplication with the t pi by 3. We need to multiply here pi by 3. Then if we differentiate sine, it gives us cos pi t by 3. So our final answer would be pi by 3 cos pi t by 3. From there we got that one. Now let you write as a velocity. We know the formula for the velocity by uv rule, u dv by dt, u dv by dt plus v du by dt in this time. So let you put here u is twice t into dv by dt, which is pi by 3 cos pi t by 3. Okay, then plus v means sine pi by t into 2, so we can write 2 sine pi t by 3. So just write in a simplified form, which is 2 pi t by 3 as a constant, it is cos pi t by 3 plus 2 sine pi t by 3, and this is our expression for the velocity. Now we are going to move to the acceleration part. Actually, to get the acceleration we have to differentiate the velocity again. So let me do that. I am writing on the below in this time. So a equals to, we are going to differentiate d by dt of velocity, and we have to apply here the product rule. We are doing directly right now, and the second part of the velocity we do not need to apply differentiate. So if we apply the differentiation here, then it would be 2 pi t, I'm writing directly now, 3 into differentiate of cos pi t by 3 gives us minus pi by 3 as a constant of t, I mean multiplied with the t. We have to write first, then pi by 3 into sine cos changes to sine pi t by 3. That's the first part. Then plus cos pi t by 3 into, if we differentiate 2 pi t by 3, we would get from there 2 pi by 3. 2 pi by 3. This is the first part of the differentiation. Now let's do the differentiation of the second part, which is 2 sine pi t by 3. So from there we can write it is 2 pi by 3, 2 pi by 3 sine converted to cos after differentiation, cos pi t by 3. So let you write in the simplified form, then we can write this one minus 2 pi square t, because we multiply pi by pi and divided by 9, then sine pi t by 3, the first part. Then second term is 2 pi by 3 cos pi t by 3. Okay, and the last one is, it is 2 pi by 3 cos pi by 3, pi t by 3, cos 2 pi by 3 cos pi t by 3. So let me see, the last two expression is here same, so we can add both of them. By adding both of them, just these two term we can add. I'm not writing again, I'm erasing and just make the first one as a double. So let me erase the one part from here and make the part double. I mean 4 pi by 3, we would get, this is the plus sign, 4 pi by 3 cos pi t by 3. So that is our expression of the acceleration. This is, we have done the first part only. Now we are moving to the second part, which they are asking to show. So just we have to put to the respective values of the left hand side and right hand side, and if we get the same thing from the left hand and right hand side, then we can say this is done. Okay, let me start here. It is the part B. I'm using the blue color right now to do the question number B. It is written on the left hand side 18 vt. V expression is, this is our velocity expression, we need to multiply with the t, then minus the displacement expression. Okay, let me do it. If we multiply with the t, then it turns to 2 pi t square, because the velocity expression, divided by 3 cos pi t by 3, then plus 2t sine pi t by t, because we multiplied that expression with the t, velocity expression, this expression. That's why this is like this. Okay, minus s is here, this is the expression s, let me put it here, minus 2t sine pi t by 3. So is it we can, I think 2t sine pi by t you can cut out from there. Yeah, let me cut out this two term. Only the part remaining from there, 3 we also can cut out from here, 6. So 6 to the 12 pi t square, cos pi t by 3 is the remaining part from the left hand side. Okay, let we move to now the right hand side, which is written here t square 9a plus pi square by s. So let me do that. Right hand side, if we simplify, then we can write it t square into 9a. Our expression of a is this, so we have to multiply with the 9. Then if we multiply with the 9, then the terms becomes minus 2 pi square t sine pi t by 3. If we multiply with the 9, then 3 then you can write here 3 4 is the 12 pi cos pi t by 3. That is the expression. If we multiply with the 9, this is the part of the 9a. I have done only the 9a part. Then the pi square s, so plus pi square s is the first part, is the s. So if you multiply with the pi square, then it turns to 2 pi square t sine pi t by 3. That the expression we got from there, which see here 2 pi square t sine pi by t, and the first term we can cut out from there. Then finally we would get from there 12 pi t square cos pi t by 3. Okay, 12 pi t square cos pi by t and 12 pi t square cos pi by t. So left hand side we got here, left hand side equals to right hand side